In this lesson, we're going to be looking at complex numbers. So you might want to just stop the video and read that first paragraph just to familiarize yourself with the topic we're going to be looking at. All right, complex numbers. Every single number out there in the whole world can be classified as a complex number. So all our work so far has been with complex numbers. We've just called them specifically real numbers. And don't you like this statement down here where it says, mathematicians created an expanded system of numbers using the imaginary unit? So let's just make up stuff. All right, to deal with this situation where you don't have a real solution, okay, mathematicians decided to come up with these relationships. So lowercase I, usually it's italicized, is equal to the square root of -1. Well, if you square both sides, you have I squared, and the square root is going to be removed on this side of the equation. So that results in the expression I squared equals -1. All right, every single number out there can be written in the standard form. Okay, and our work before looking at I, has really had us just looking at real numbers where A right here represents those real numbers. So let's look at this example. The square root of -9 minus 5. Well, we've known up until this point that we can't have negatives underneath the square root, but now we can. Okay, so how we would handle that would be something like this. Okay, you can take and rewrite -9 as 3 squared, which is 9, and we can say that we're going to be multiplying that by -1. All that needs to be underneath the radical. And we still have -5. All right, to simplify that further, we know the square root of 3 squared is just going to be 3, so that'll come outside the radical. That takes care of this right here. And then we're left with the square root of -1 underneath the radical, and then -5. All right, well, just a few lines ahead of us, before us, previous to us, we defined I to be the square root of -1. So we're going to replace the square root of -1 with I, and the result is 3i, and then the -5. Okay. Oftentimes you'll see it written in standard form, rearranged. The real part first, the -5, the part that doesn't have the I, the imaginary part. Usually you see it rearranged and written in this format, -5 plus 3i. Let's take a look at a definition and then we'll begin our work with imaginary numbers. All right, so A and B are real numbers. Then the number A plus BI is a complex number. And again, every number out there is a complex number. And it is said to be written in standard form when it's written this way. If B equals 0, think about what happens here, that zeroes out. Then the number A plus BI would just equal A, is the real part or the real number. If B does not equal 0, then the number A plus B is called an imaginary number. Okay, what about a number of the form BI, where A is 0, but B does not equal 0? Well, that just means our number is called a pure imaginary number. There is no real part. Our work is going to be concerned with what are some of the operations we can perform with complex numbers. All right, let's look at this first piece of information. Additive inverse. So what is an additive inverse? It means you're going to be adding. Inverse means you're undoing. An additive inverse zeroes out the complex number. So it's basically thinking, what can I add to what I'm given so that I get 0? All right, if we have a complex number such as A plus BI, then its additive inverse has to be the opposite of A minus BI. If you're thinking about collecting like terms, the result would be 0. So just additive inverse, if you're asked to find the additive inverse, take the opposite of both parts or all parts of that imaginary number that's written in standard form. Okay, continuing here, we're going to be doing some examples with complex numbers. Okay, so a couple of examples here. Example 1, just think, just like with polynomials, collecting like terms. All right, so for example number 1, we have 3 complex numbers in standard form, and we're supposed to add them. So we're going to add the real parts and then the imaginary parts together. Okay, let's first of all go ahead and rewrite it. I don't need the parentheses on this first complex number. It serves no purpose. Okay, when I'm adding, the parentheses don't serve a purpose there, so I'm just going to remove the parentheses. However, right here, if I'm subtracting a quantity, I have to distribute the -1 through, so we're going to have -7 minus I. All right, let's go back and collect all the real parts. So 3 plus 4 is 7, but 7 minus 7 is 0. So actually we don't have a real part. And then we're going to have 2I minus another I. Oh, what a coincidence. The result is 0. We don't have a pure imaginary part. We don't have a pure real part. Our answer is 0. It's still a complex number. I could write it as 0 plus 0I. Kind of pointless. Well, that's my answer, 0. That was weird. Let's look at example 2. Again, let's take care of removing the parentheses, either by distributing the negative through or just simply removing the parentheses because we're adding. All right, 3 plus 2, 5 minus 5 is 0. We don't have a real part. When I collect the imaginary parts, I'm going to end up with -2I. That's my answer. It's a complex number, but specifically, it's a pure imaginary number. Let's look at another example. All right, so if you take a look at number 3 compared to number 1 and number 2, you can see that I have some radicals with negatives underneath them. So what's going to happen there is we have to take care of that first. We have to rewrite those radicals, okay, in the I form, and then we can proceed like we did in number 1 and number 2. Okay, so put yourself a little note over here, okay, and make sure that you remember that you have to rewrite in I form first. Okay, we'll kind of try and do a couple things at one time, but not too much to confuse ourselves. Okay, so looking at this first quantity right here, I'm going to remove the parentheses. It serves no purpose. Okay. But what I do notice is that I can simplify the square root of 27. It's 3 cubed. Okay, and that's times -1. I'm going to go over here and do a little work over here, and then I'll come back and take care of finishing this right here. So I'm going to distribute the negative, so that's going to become plus 12, and then minus the radical -48. Let's see, how can we rewrite 48? Well, I know that's 16 times 3. That's not real obvious, but you'll get used to it. 48 can be written as 16 times 3. And then I still have a -1. Also, 16 is a perfect square, so that'll be easy to simplify. So let's come down here. Maybe I should have rewritten this as 9 times 3 because the square root of 9 is 3, but that's okay. Just trying to show different ways too that you can proceed to simplify complex numbers. All right, so let's work down now. 5 plus, well, if this is 9 times 3 or 3 squared times 3, then a 3 will come out, leaving 1 3 inside. But remember, we still have that pesky little -1. We'll take care of that in a minute. Square root of 16 comes out as a 4. We're left with 3 times that, again, pesky little -1. This might be too many steps for you. Feel free to cut it down if you want, but there, there's always a risk with trying to combine too many steps in one. Too many, I guess, steps in one step. All right, let's see. We've got 5 plus. Okay, let's take care of this right here. Okay. This square root of -1 is going to come out as an I. So common practice has us put it behind this constant multiplier of 3, okay, but before the radical. Plus 12 minus, okay, think about what I'm going to do here. Okay, I'm going to pull out an I. It'll replace the square root of -1, but I'll leave the square root of 3. And again, we'd usually put the I right here in between the constant multiplier and the radical. Okay. Wish we were done. We have a little bit more work to do. We've got to clean up any like terms. So I see 2 real parts. 5 plus 12 is 17. And then I do identify that the 2 imaginary numbers right here are exactly alike. So I have plus 3 and minus 4. So the result would be minus 1 I square root of 3. Again, here's our real part. Our imaginary part, it's not a pure imaginary number because we have a real part. Okay, but the name of that number can be called a complex number. Okay, so I've added some more examples, and these examples are going to include more operations other than just adding and subtracting. We're moving into multiplication. All right, example 4, square root of -3 times the square root of -18. Okay, what you don't want to do is you don't want to multiply these two negatives together and get a positive. What you want to do is you want to tackle each of these radicals with a negative underneath it first. So I would rewrite this, okay, as I square root of 3 times, let's come over here. We know that this is going to come out as an I, but we have to simplify the square root of 18. Square root of 18 is 9 times 2. So square root of 9 is 3, so I'll pull out a 3. I'll have the I come out, and I'm left with the square root of 2. So you want to simplify each of the radicals that have a negative underneath them separately, and then continue from there. You wouldn't want to multiply this together and say that this is the square root of positive 54. 54 coming from 3 times 18, and then simplify from there. You have to tackle them individually first. So now what we have is 2 imaginary numbers that we have to multiply together. So I times 3i produces 3i squared. Now we can multiply the 2 radicals together because neither of them have a negative underneath it. That requires simplifying first, and we're going to get square root of 6. Well, are we done? Almost. Okay, look back up at the beginning of your notes. I squared is equivalent to equals -1. So anywhere you see I squared, you're going to replace that with -1. And that's a multiplier. If I squared equals -1, then it's 3 times -1, which is -3. So I squared gets replaced with -1. It just changes the sign, and we lose the imaginary part. So actually, our answer is a complex number, but it's a real number. There is no imaginary part to it. All right, let's look at number 5. All right, this requires foiling. First, outside, inside, and the 2 last terms. All right, the product of the 2 first terms is 8. The outside is going to be 6i. The inside is minus 4i. And the 2 last terms multiply would be minus 3i squared. All right. Ooh, let's see, we don't want that. All right, first glance through, we can't really tackle these i's right here. We're just going to have to work with them the way they are. But if you look at I squared, I'm going to be able to replace I squared with -1 in my next line. And when I replace it with -1, remember what we're doing is multiplying by -3. All right. So I think I'll bring down the 8. I'll go ahead and clean up these like terms. So I'll have plus 2i. And I have minus, actually I'm going to have plus 3. Let's go back and finish adding the real part. So we're going to have 11 plus 2i. So this complex number has both a real part and an imaginary part. All right, so example 6. We have square root of negative 10 times itself. If you wanted to expand it. Now, in this case right here, if you're squaring this, okay, think about removing the square root. The square on the square root would result in us having an answer that is actually what's underneath radical or negative 10. So if I'm trying to guess and just kind of think ahead, what would my answer be once this problem is all completed? I think the answer is going to be negative 10, but let's see if our work over here is going to support that. All right, just like example 1, okay, let's not multiply negative 10 times negative 10 and get positive 100, because then our answer is just positive 10. Okay, think about what we did in example 4. You first have to tackle the negatives under the square root. So this becomes I squared of 10 times I square root of 10. I times I produces I squared. And square root of 10 times square root of 10 is just, oh, I need an I squared, sorry, is just 10. Remember what we mentioned? I squared is equivalent to negative 1, so negative 1 times 10 would give us negative 10. Mathematically, what you want to do is you want to pull out the negatives as i's first and then continue from there. Because otherwise, if you multiplied these two radicands, is what they're called, radicands together, you're going to get a positive 100, which would result in a positive 10 answer, which is not the correct answer. So the next video, we're going to do more work with operations on complex numbers.